Okay, use the chain rule to find the derivative of the following function. Type your answer without fractional or negative exponents. Use squirt x for root x. Okay, maybe we can rewrite this. We should probably rewrite this as like 10 and then like 10x to the 9 plus 3x to the 5. And we'll rewrite that square root to the power of 1/2. And I'm going to do that so that I can kind of think about this. Ooh, this is fun. We can think about this as like u, and maybe I'll write this in green over on the side. So let's think about u as 10x to the 9 plus 3x to the 5. And we know the derivative of u with respect to x is going to be 10 times 9x to the 8 plus 3 times 5x to the 4. Or 90x to the 8 plus 15x to the 4. So we have the derivative of u. So if I want to find the derivative of f with respect to variable x, I can actually take the derivative of f with respect to variable u and then multiply by the derivative of u with respect to x. We already have that second piece. It's right here. So what we need to do is we need to figure out what the derivative of f is with respect to u. So let's rewrite f in terms of u. So we have 10u to the 1/2. So if I can find the derivative of this expression with respect to variable u, I pretty much have this problem all sorted. And this is a power law. We can do 10 1/2 u to the negative 1/2. So there's my derivative with respect to u. We got to multiply this by 90x to the power 8 plus 15x to the power 4. And then since we're essentially looking for something in terms of the variable x, we're just going to take our expression for u, which is this one, and we're going to sub that back in right here. So that should give us 10. Well, we can probably get rid of this 10 and this 1/2. Let's write this as 10 divided by 2, or 5. And then we're going to have 10x to the 9 plus 3x to the 5 to the power negative 1/2 times this other derivative that we found in green. Now, from here, I think it just says we want no fractional or negative exponents. So let's drop this particular negative exponent down into the denominator and rewrite this as a square root. So we'll finish this up by just writing this as maybe like 5 times 90x to the 8 plus 15x to the 4. And then in the denominator, we'll have our 10x to the 9 plus 3x to the 5 under the square root. So that should be our f prime of x.
Unique axioms.
Nice song, Anders. Nice song. We will be adding that to the playlist for sure.
Cold steel strong under cherry blossoms take. History lives in the moves we make. Step to the future, leave behind mistakes. Embrace the pulse, in sync we shake.
All right, returning back to our question here. Let's rewrite f of x in terms of the function u. I'm going to call it 2u to the 16, and I'm going to take all of that stuff inside the brackets. I'm going to call that u. I'm going to go ahead and find the derivative of u.
Conservative and the poli-sci grads aligning with NDP. Analyze their platforms critically, which aligns with your zeta values.
But that's not always true. That's not always true. People have different beliefs, so you can't base it off of like one particular characteristic. All right, so we have the derivative of u. Oh, actually, I should finish this off. We have the derivative of u with respect to x. So this should give us 60x to the 5 minus 36x cubed. And the derivative of f with respect to u should be 2. And we got 16u to the 15. That's going to be 32 u to the 15. Did I get that right? 16 times 2 is 32, right? So our derivative of f with respect to x should be the derivative of f with respect to u times the derivative of u with respect to x. You'll notice that this is one of the very few times in my life where like I really appreciate Leibniz notation when working with the chain rule. It makes the chain rule feel so much easier. Yeah, so like Leibniz for the win here, I think. Okay, and once we have multiplied these two things together, we just need to go back, find our expression for u, and plug that in. So we'll get 10x6 minus 9x4 to the 15, and then we'll get 60x5 minus 36x to the 3. Boom! There's question 2. So here's how I would set this one up. I'd say cosine of u, and then maybe make u the inside function. And then we know that the derivative of f with respect to x should be the derivative of f with respect to u times the derivative of u with respect to x. If I take f with respect to u, the derivative of cosine is negative sine, right? Negative sine of u. And then the derivative of u with respect to x is 4. And then the last thing we want to do is just kind of back substitute 4x plus 6 in. So we're going to get something like negative 4 sine of 4x plus 6. And they want us to find f prime at 5. Is that defined? F prime at 5? Negative 4 sine of 26? Is that... Can we even do that? DNE? Does not exist? What's happening here? Why are they giving us like some crazy gigantic number to throw into the sine function? That doesn't make any sense. Oh, I guess this is the x coordinate, right? And then we're going to get some kind of output coordinate. So they're going to take this input as radians. Is that how this is going to work? And then they're going to give us some weird kind of like, yeah, decimal number output that's between -1 and 1. So this is, my calculator is viewing this as 26 radians. And it's giving me an output of about 0.76. I should maybe... Oh, they get negative what? Negative 3.05? That doesn't... What? yeah, exactly. I was confusing my inputs and outputs. So, why are they getting negative 3.05, though? That seems bizarre. Oh, because we have to multiply... I see. We have to multiply this by -4. That's why. Okay, so that's how they get their negative... So they are using radians. So we should probably... So if my students are watching this, you're going to have to set your calculator to radians to get that answer. Otherwise, you're going to run into some problems. So what did we say? This is about negative 3.05. So just be mindful of that. If you need to move your calculator into radians and you're unsure, just let me know, and we can make that happen. What's the easiest way to use Leibniz notation here? Because this one's going to get a little bit funky, isn't it? This one's going to be sine of negative 6x to the 9, but this part's squared. So I guess we could do something like f could be negative 7u squared, where u is equal to sine of negative 6x to the 9. And then we could go one step further if we wanted to and say we have negative 7u squared. U is equal to sine of v, and v is equal to negative 6x to the 9. So now we can actually take the derivative of f and u and v all one by one. So let's do the derivative of f with respect to u should be negative 14u. The derivative of u with respect to v should be, derivative of sine is cosine, right? So cosine of v. And then the derivative of v with respect to x should be negative 6 times 9, so negative 54. x to the 8. And then we just have to figure out how to put all of this together. And Leibniz rule lets us do that pretty easily. So if we want df with df over dx, or the derivative of f with respect to x, we need df du times du dv times dv dx. So we just do a big chain of these three multiplications, and then we'll have to just work on maybe some back substitution here once we write this all down. So here's our df du. We're going to multiply that by cosine of v, and then multiply that by negative 54x to the 8. And we need to go back and figure out our subs. So here's our substitution for v. Let's see, what is negative 14 times negative 54? Do you have an Independence Day, or are you still technically part of England? I think we're still reasonably part of England, although we do have Canada Day, which is July 1st. So our fireworks are always a couple days ahead of your fireworks. 756. X to the 8. Well, actually, I don't like that. I don't like it. Let's make these substitutions first. So negative 14, oh, let's do it in black. Negative 14 sine of negative 6x to the 9 times cosine of negative 6x to the 9 times negative 54x to the 8. That's probably fine. I don't think we need to go any further than that. It's actually really easy to mark that on a quiz or a test, because you can just be like, boom, boom, boom. Those are all the three pieces that we need. I'm probably just going to leave it there. I don't think it asks me to simplify, right? But there you go. There's an example of using the chain rule a couple different times. All right. If I was explaining this just for an introductory kind of chain rule business, I'd probably just set this up as like a 7 cosine of u, where u is equal to cosine x. And I would say that the derivative of f with respect to x is equal to the derivative of f with respect to u times the derivative of u with respect to x. Now, f with respect to u should be 7 times negative sine u. And then the derivative of u with respect to x should be negative sine of x. Oh, Obi, I see you're playing Elite Dangerous. I should really stop those pop-ups from coming up on stream. We'll multiply these negative signs together and the 7, and we'll get sine of u times sine of x. So sine of u sine of x. We know that u is equal to cosine, so we can make a substitution. So sine of cosine of x times sine of x. Something like that is what we're looking for this particular question. Is there an easy way to deal with this? Man, we could probably say that this is like u times v, where u is equal to 7x squared minus 4, and v is equal to negative 9x squared plus 4 to the 14. And we know that if we want to find the derivative of f with respect to x, it's the derivative of the first times the second plus the derivative of the second times the first. So we need to find u prime as well as v prime, and we have to do that using the chain rule. So we're going to bring our 4 down and subtract 1 from the power. We need to input our 7x squared minus 4 back, and then we need to multiply by the derivative of the inside function, which is 14x minus 0, so 14x. And then we want to do the same thing with v prime. We want to bring that 14 down, subtract 1 from the power. We're going to input this expression back in and then take the derivative of that inside expression. So negative 18x. Negative 18x. Okay, let's finish this up. So u prime we found was 4 times 7x squared minus 4 to the 3 times 14x. And we need to multiply that by v, which is negative 9x squared plus 4 to the 14. Then we need to add to that v prime, which is 14, a bunch of stuff, to the 13 times negative 18x. And then multiply that by u. So this is going to be a really, really messy final answer. I will highly recommend not to multiply this out and simplify. And leave it just like that. Okay, we got a function of s. Then g prime of s is blah, g prime of 5 is blah, and we got to do some second derivative stuff. So can we do this mentally in our heads? Probably. So if I want to do the chain rule, I'm going to bring the 6 down. I'm going to leave the inside the same. Decrease 1 from my power. And then I need to multiply by the derivative of the inside function, which is just the 4s minus 5. So I need to multiply by 4 at the end here. And then they want us to evaluate this at 5. So we can probably just bust out the calculator. Let's go 6 times bracket. We'll go 4 times 5 is 20. Take away 5 to the power of 5. And let's multiply that by 4. That's huge. I guess that's not surprising because we have a really big power. This is 15 to the power of 5. So this is really big. I should probably not touch the calculator. Fuck, I knew it was going to do that. I knew it was going to do that. I can't hover my, for some reason, I don't know why, I cannot hover my pen over the calculator, otherwise the calculator just breaks. So let's try to grab that answer again. So this is 20, this is 15 to the power of 5. So it's 1822, 1822, 5000. So it's a pretty big number. Now we could probably take g prime and just rewrite it as 24, 4s minus 5 to the 5. And then we can take the derivative. We're going to have to multiply 24 by 5, but we can do that. So 24 by 5 is 120. We'll keep the inside the same. Decrease the power by 1. And then we need to multiply by 4 again. Because 4 is the derivative of that inside function still. So in this case, we need 120. That's not 120, that's 220 times 15 to the 4. 15 to the 4 times 4. That's still pretty fucking big. That's 1, 2, 3, 4, 5 zeros. 2, 4, 3, 1, 2, 3, 4, 5. You are so right.